If you just let the system loose and do not screen it for potential threats, then really bad things can happen.
Welcome back to ChatRog, where we explore the moral questions raised by the development and use or misuse of artificial intelligence. I'm Roger Steare, the corporate philosopher. My guest today is Andreas Maier, professor of pattern recognition at Friedrich Alexander University in Erlangen, Germany. He leads a research group that looks at how machines can recognize patterns in images, in speech, and in data, and turn them into sound decisions. Much of his work focuses on medical imaging, teaching computers to help doctors read X-rays, CT scans, or ultrasound images more quickly and accurately. Ultimately, Andreas's work asks the questions, can we trust AI when the stakes are life and death? Andreas, welcome. It's a pleasure to have you with us.
Absolutely. It's a pleasure to be here.
Thank you. So let's dive in with this huge question. Can we trust AI when the stakes are life and death?
Well, in particular in the medical domain, the stakes are virtually always life and death. And there is also limits of resources. And we hope that we can use AI in order to distribute resources and use them more efficiently. So the question of life and death, for my opinion, is always that we try to keep the medical doctor in the loop and that the decisions are done by man and not the machine. We want to, create more time, useful and also more easy accessible processes such that we can accelerate on the work that a single human can do. So I would not put everything into the hand of the AI, but of course there's lots of things that can be simplified. Documentation duties, screening, and so on. Always processes where you have a human in the loop, and also processes where if you have AI recommendations that can essentially be reconsidered in the next stage. If you go to screening, you want to be very sure that you do not reject somebody who has a pathology, but you also want to be sure that you are not admitting too many people for further diagnosis, although they're perfectly healthy, because this would just overrun the entire health system.
What is this technology capable of doing and not doing in assisting the doctor?
So I would say it is able to harness lots of data, that you do things like in digital humanities, it's also called distant reading, that you're able to process much larger databases, have larger comparison groups, that, the comparison group that a medical doctor has in his hospital, over time, it can reach thousands of patients. But with the right AI systems, you can expand this to 10,000 and even millions, and it can be done. But, this is something that helps you, for example, in rare disease. This is a topic that is something where I think that the AI methods can really help, because you have also, if you're trained as a medical doctor, you don't see these cases very often. But obviously in these cases, some additional consultation can be very useful. I think we will have things like automated surgery and like robots that do surgeries entirely on their own and things like that. I think this is much, much further down the line. I mean, you see that people are hesitant with autonomous driving. So in particular in the EU, we have pretty strong regulations in order to make everything safe. And obviously there's very good points for that. Although, I mean, some of these systems can, if you look at the systems that you have in your car, they can help you drive your car much, much safer and with much less cognitive load. But in the end, it's you who is in the loop. And the same thing, I think, has to be done in surgery. I mean, you can learn to drive a car in a couple of weeks, but it takes years of training to do a surgery. So obviously, that's a much more difficult problem.
Thank you. When you were talking about the size of the databases, and you mentioned that some diseases are quite rare, are you already exploring the opportunity to hook up with international databases so that you actually got that scale? Because, there are, 8 billion of us on the planet. Not everybody has a medical record yet, but there must be huge opportunities there for collaboration.
There are huge opportunities, and we are building we already have, as researchers, worldwide networks. We're working with the United States, we're working with India, we're working with China, because representation is also a key issue. If you build a system only for North America or only for a European population, it may not work very well in Asian or in populations across the world. Yeah, and obviously we have to build the systems in a way that all groups of populations are correctly represented. We're also increasing our ties with Africa, and not just because of the data, because there's also many talents in Africa and they lack resources, access to compute, and so on. So there's a very interesting community in the Mikai society called Afrikai. So yes, this is a worldwide endeavor, and we need to place it as a worldwide endeavor just because of the huge risk of misrepresentation.
So please tell us a bit more about the Pattern Recognition Lab and how you got interested in setting this up in the first place.
Yeah, so the Pattern Recognition Lab here in Erlangen-Nuremberg University is actually founded in 1975. And I just did a little bit of research because this year is actually our 50th anniversary. So I'm already the third head of the lab, so I'm in the third academic generation here. And I actually had to do a little bit of homework myself because I tried to figure out how was the lab founded and so on. So I had a couple of conversations. Turns out that in 75, the Pattern Recognition Lab here has been funded because the local computer science group here was able to acquire funding for creating a new professorship in pattern recognition and also associated machine learning. And at the time, most of the machine learning efforts, what we know as machine learning today, were actually located in electrical engineering and signal processing. So there were dedicated AI labs, obviously in the United States and also already in Europe, but in Germany, the Pattern Recognition Lab is the first of its kind going into this very strong learning direction and not so much as symbolic AI, really the pattern extraction that then later became very well known as machine learning. So I'm very happy to be here. My personal journey is I actually started studying computer science here in the same city, in the city of Erlangen. And it's actually quite interesting that I ended up heading the lab where I actually started studying. And I specialized in pattern recognition in the year 2002. So it's already quite some time ago. And then went to other places. I spent some time in Japan. I did a very nice experience as postdoc in Stanford. Also went to industry. Siemens Healthineers was a very nice experience to be there in the innovation department, work on research and design. And then I actually came back to the university, happened to have a very good offer from my alma mater. So I returned to the very lab where I started my journey.
One of the things that I think you've talked about is your concerns around the current AI performance metrics misrepresenting reality. Can you unpack that for us as amateur listeners?
Well, obviously, the whole thing of medicine is that you have several factors that change your population all of the time. So, for example, new diseases emerge. We've just went through a pandemic of an entirely new disease. So you cannot rely entirely on the data that you have learned from previous years. But machine learning exactly works that way. It relies on previous data, and the data has to be representative. But as soon as there is a change in the underlying data, then obviously these systems need to be adapted. And I think a good way to achieve this, and it's very similar to the control mechanism in place in virtually all of the medical diagnosis systems, is persistent quality control. So you have to check the patient outcomes. And as soon as you realize that there is certain patient groups or certain diseases emerging and the previous treatments are not as effective anymore, you need to be able to react to that and then essentially rethink your design. So you have a continuous loop in medicine all the time. And obviously the same thing will also hold for medical AI.
Thank you, Andreas. So what could go wrong here? What's the problem?
Yeah, well, obviously there's multiple things that can go wrong. And we've seen that already in other areas of medicine. For example, it could turn out that your quality assurance is simply insufficient. You obviously have to track the outcomes. And, you know, a lot of the medical health records are being rehauled across Europe. So we are going towards digitalization, which is a really big relief, not just because we will then able to have data and access it for training, but it is also a constant tracking that allows you then to adapt to new diseases that may occur, or also side effects that you have not foreseen during your development. I mean, AI, many of the AI systems, in particular large black box systems, they are very difficult to explain, right? And in these cases, you would need the quality control. And we have other systems that, to some degree, also have a certain black box characters, as we see it in the vaccinations. And in the vaccinations, you have to check for side effects. You have to have a structured reporting register to have all of the side effects and the adverse effects that have occurred. And I think you need something for AI as well. But then again, you also have to be very careful with these reporting systems, because if they're open and validated and do not stem eventually, if they do not stem from a trusted source and just anybody can insert data, then we've seen that platforms like that one have accumulated for particular diseases or for particular vaccination, all of a sudden, within only very few months, a lot of reports. And then you have to ask the question, okay, where are all these reports coming from all of a sudden? This vaccine has been around already for quite some time, and suddenly there is a surge of reports. So if the source is not trusted and everybody is able to really input data, things can very quickly also get essentially hooked up by certain campaigns that can be run on the internet. So if you have a digital system where have trusted bodies that input the information, then I think these events can be prevented. But then it also opens the risk that if you have a trusted body that is supposed to do the reporting correctly, and they're not doing it in a timely manner, in particular in Germany, I think we still operate on fax machines in some medical practices that can cause significant delay. Obviously, everybody in the system has to be trained appropriately to do the reporting correctly, because if that's not the case, people are not trained, then there's also no side effects because they're simply not reported.
You mentioned trust and transparency and interpretability. That's obviously a big general issue for the use of AI in all applications. So we're interested in, when should AI decisions be explainable to patients as well as doctors? When do you think that's important?
I think it's important for rare and complex cases. If I talk to my medical colleagues and ask them about explainability, and then they look at me and say, look, in this case, this is a chest x-ray. I have in my practice 30 seconds to rate the case. And I don't care why the system is right, but it needs to be right. And if it's wrong, I can't use the system. So it needs to be reliable. It needs to work. In the high throughput tasks, the systems just have to be very reliable. The explanations, at least to what I hear from my colleagues, are not of such great importance, because they say, I look at the image and I know the explanation. Yeah, I don't need a system to tell me that this is the heart on this image is too large, is extended, and that there is a lesion in the lung. I immediately see it. I don't need an AI explanation for that. But if you come to the difficult cases, multimorbidity, aging populations, they have not just a single diagnosis, but they have a whole patient history, and every patient is very unique and has also very unique needs that have to be met with the treatment, with the diagnosis, and so on. And in these cases, I think the AI should provide explanations. But I think that in these cases, because they are rare, they need more time, they also can be something like a second opinion. A system that you ask for, like, I think it's that case. What does the AI say? Or the AI says this case. They disagree. Maybe I ask a second colleague, and I know he's an expert in this field, and let's just consult him as well. And you see that for the complex cases, like for example in stroke, you need to be able to act very, very fast to get the perfusion into the brain again after a stroke. But then again, depending on the area of the brain that is affected, stroke can have also a multitude of different outcomes. Treatment has to be organized in a very structured way. And you see that the stroke units that have emerged, they already have committees of experts. They have a neuroradiologist, neurologist, they have a speech therapist, they have all kinds of experts that come together. Obviously, they have to be efficient because there's not so much time for the patient and there's like many patients coming into a stroke unit, but they liaise anyway with multiple experts. And if they are able to consult an additional AI system that can point in rare cases towards new directions, they can probably use this in a safe and adequate manner. And so I think there's like different thresholds, different tasks, different levels of AI use that we will see in the future. And we have to obviously think about these workflows. We also have to understand, as if you work on medical AI in general, if you do medical engineering, the first thing that you have to learn is the current medical workflow and how the patient treatment is done right away. If you come into the place as a software engineer and say, oh, I have this beautiful new algorithm and it's just marvelous, and it's actually some action that has to be done in real time, the patient is on the table, you need immediate feedback, I say, yeah, but then I have to solve this system of equations and that takes half an hour. And then the medical doctor say, okay, throw away your algorithm, it's completely useless. I need the support now. But this is not always the case, right? If it's a diagnosis, sometimes patients have to wait, because there's a histology made, they have to ship samples from one place to another. It takes time anyway. Then you also have time for compute. So you have to understand the workflow, you have to understand the requirements on that workflow and the actual clinical needs before you can go ahead and build medical AI successfully.
You've clearly articulated something we've discussed with other guests, which is the difference between the capability of the human mind, which is both a combination of rational calculus, positive emotions, and intuition from experience. And at the same time, an AI has an ability that we can never have, which is the ability to interrogate and interpret massive databases. Are you saying in your last answer that actually there is a wonderful combination there, a collaboration there between, if you like, the brute computing power of the AI and the deep intuition and experience of the human physician?
I think it can be very efficient. But, in the end, what counts is the patient benefit. Whatever we do, only if the patient has a better treatment, has more safe diagnosis afterwards, the systems will prevail. If it's fancy and just sounds good, but doesn't make a difference in clinical practice, then these systems will disappear again. And I've seen that with numerous technical innovations. They sounded super thrilling and they were very, very well elaborated, very well engineered. But in the end, they simply didn't take off because the clinical need just went into a different direction. Or there were other obstacles in the way that turned out to be more difficult than we thought. So the patient and, of course, also the physician are in the center of everything what we're doing. If it's an obstacle for the physician and says, okay, this just slows me down, it makes me more work, also these systems will not work in clinical practice.
Do you find doctors are reluctant to question the decision of the machine? Is this a bit like the story of the emperor's new clothes?
I think some like to use the systems, and then obviously you have to be very careful because after a couple of good decisions, then the trust goes up. And then you have to be very careful that your system doesn't introduce new bias and that there's an over-reliance on the AI. So this is one thing where you have to be careful. And if these over-reliance issues, you will only see through good quality control. Because in the end, if there is an over-reliance, the AI does the wrong recommendations, it can also mislead the medical treatment. So this is an issue that has to go under quality control. And then obviously there's also several colleagues that are hesitant with AI. And I've seen that. Unfortunately, we couldn't publish the data, but it turned out we were working on image quality improvement. And I think one of my PhD students, he made a mistake, and he accidentally told the physician that all of the images have been improved by AI. But it turned out that one of the 4 different choices that they had is just a image that has been taken with higher X-ray dose in this example. So the others were denoised, were low dose, and one of them was high dose. And it turned out that there was a group of these, so they, not all, but there were several individuals in the study that evaluated all of the images as inappropriate, although one of them was actually appropriate. But they knew all of this is AI, and they gave worse scores even to the one that was the correct, the high dose image. So there can also be a negative bias just because people know that this information stems from AI. So it works both ways.
Thank you. I'm going to come to bias in a moment. Before we leave this current thread, when things go wrong, when AI contributes to a bad decision or causes harm to the patient, who's responsible? Who do you think should have responsibility for that? And where does it lie now?
This is, so I think if you have to look at the different perspectives, and in particular, the vendors of medical engineering devices, they always like to have the physician to do the final decision, because this is also their way out to essentially put all of the responsibility towards the physician. Yeah, then so this is something that comes from the manufacturer side, where they like to push away the responsibility. And then there's also a couple of things that we really have to think about. If you were to make an AI system responsible, then obviously there's damages that will be caused. And the damages, the liability, they can be essentially compensated by some kind of insurance mechanism. But there's a couple of things that you cannot do with an AI. For example, you cannot send the AI, if there is a really hurt to a human done, sometimes if there's a severe misconduct, then you would send a treating physician, not just a monetary punishment, but they may also end up in having caused harm to another individual. With an AI, you can't do that. You can only do monetary compensation. Probably if it's really consistent and if somebody has been cheating the system, think of Dieselgate or something like that, then you really would have to demonstrate that this is the case, that there has been really misconduct in the system design and they neglected possible factors of risks and have simply circumvented this. And then probably you could go towards the vendor and also make a case that even some of the engineers who actively circumvented the risk mitigation measures. So I think these are possible scenarios that I could think of. I mean, probably much of this simply also follows medical device regulations as we already have them. So in the medical world, having devices that are involved in very hard decisions is already rather common, I would say.
You've explained your concerns about AI systems in medicine being biased. How much of this comes from the training data, which perhaps contains human biases, and how much from the systems themselves?
Well, it probably depends on the system design. If you're designing a system that is entirely built on the statistics of data, you probably have the bias in the data, and you will have to make sure that your data is not suffering from those biases. The other point is, of course, these are algorithms, right? These are systems that lead toward a decision. And we have seen that because people wanted to mitigate bias, they have introduced essentially rules or custom prompts or different ways of how to try to avoid bias. But obviously, there have been plenty of cases where people were exploiting these bias mitigation measures to create something else dreadful. I mean, think of the images that they created from German soldiers of World War II that then obviously were also very diverse. Yeah. So if you know how a system works, there's all kinds of ways how you can probably attack such systems. So in the end, you have to make sure that the systems are used in an appropriate way, that people who use the systems are trained also in a way that they know what they are doing. And I think if all of these criteria are met, you can operate such a system safely.
Can AI be trained to fix itself here when it comes to bias?
Well, it depends, of course, what your definition of AI is. If it's merely data analysis, you could probably say it can be done. I think the key problem here is your definition of bias. We've seen that bias itself is very hard to define. You essentially continuously have to scrutinize whether you have missed a certain bias, right? Because you collect data, then, I mean, in the medical domain, we have also the intended use. So if you design a medical product, then you design it to be applicable towards a certain disease, towards a certain pathology, and also towards a certain patient range and patient population. And this also helps us to structure our software and medical products in an appropriate way. But as soon as there is a shift in the population, let's say, we have the aging population, and we probably have to rely on many immigrants coming to the country simply because we are running out of workforce. This will introduce a shift in the population, obviously. This also means that you have to continuously monitor whether the systems are still working correctly. You probably also do that with statistical analysis, and maybe at some point also AI, checking on other AI whether it's working correctly.
I'd like to move us now to ethical principles and moral philosophy. So, which ethical theories guide your views and your colleagues' views about the right way to use AI in this space?
Well, I've been looking a bit into ethical theories, and to be honest, I think one ethical theory that is very commonly used is that, in general, in the medical domain, right, is that you try to maximize the pleasure for everybody with the resources that you have, right? That you, I mean, also in the UK systems, you have essentially these quality of life measures where you evaluate the different interactions and also different interventions on health simply by improving the quality of life, and then you put it into context with the amount of money that they cost. And then you have a certain amount of money in your insurance, and you're investing it in a way that you're on average maximizing the quality of life for everybody who is participating in the system. So this meritocratic approach, I think, is very, very common in many of the medical insurance systems, as well as medical device regulation and the like. And I think very similar approaches would be rather easy to adopt also in the medical AI domain. Also, the insurance companies and so on, everybody in the medical system is already used to this way of thinking. So this is probably something that people are already looking into, and they already have their mindset set up that this is how they pursue ethics. I mean, you can think of other ethical theories, but I'm not sure how you would adopt virtue ethics now in this domain, because, I mean, in the end, we rely on quantification and distribution of the resources that we are available. So this one is very compatible with the system. But if you have a better approach on how to do that, I might be convinced. So I would be very open to discussing this.
So thank you. Apart from virtue ethics, the other one which I'm familiar with is that the purpose of medicine is to relieve suffering. And the context there is that we're all going to die. It's the quality of life. Now, you can look at it from a utilitarian perspective, which is the greatest happiness or pleasure for the greatest number. We can also flip it around and say, well, actually, the purpose of medicine is to relieve pain and suffering on the basis that we're all going to die. So that would be another one, but it's not particularly popular within medical ethics as a view. It's an older moral philosophy in line with the ancient Hippocratic Oath, I think. So a subsequent question for us is, medicine is an area where it's often said machines will never replace humans. Do you agree?
I'm not sure if that really makes place or makes sense to replace humans entirely by machines, because, if you only have the machine doing the entire medical treatment, I think there's also something missing. And I'm not sure if the emotional aspect that also a successful treatment has to convey can be done entirely by a machine. I mean, if you look into science fiction, you have then a human embodiment of a machine. Like in Star Trek, you have the medical emergency program then that kicks in, and I think it's Star Trek Voyager where they have that. But also in this case, you have at least some machine or artificial intelligence that takes over some human embodiment. So I think it's probably encoded into all of us that if we have medical pain and suffering, that we want to have a human in the loop, because we probably will not easily trust a cold medical system like a medical pod where you just lay down and say, oh, something's wrong with me, please fix it. This is a bit of a very technical way of looking at the body, but we are more than that, right? We have also other desires and needs. So I think it's probably not something that will be very fruitful.
Yes, I mean, this is a very interesting area. As you know, there are bots and other AI mechanisms which can provide people with mental health support who can't otherwise get access to mental health support because the system is overloaded, particularly with young people. There are plans to introduce AI systems and robots into homes for the elderly, care homes for the elderly. If someone has Alzheimer's, there are interesting experiments going on. So it's not just a question of totally replace, but in line with an earlier question, what do you think would be an ideal blend, given the fact that human beings are very good at just putting an arm on the shoulder and reassuring someone who is afraid of a medical diagnosis, but bringing in the power of an AI system to actually help us heal and cure or relieve the suffering for millions and billions of human beings? Our healthcare systems are overwhelmed at the moment in every aspect.
I agree. And so obviously the healthcare systems are overwhelmed. The key question is how you can do that in a responsible way, right? So in particular, yes, the treatment, psychological treatment is very expensive. It takes a lot of time, but it's also successful and it helps. And I mean, one thing that is very important in this type of treatment is the personal bonding, the trust that is established between between the patient and the person treating. And the question is if this can be done if you outsource it to like many different systems like ChatGPT. I mean, I can think of solutions where you have essentially one person in the loop and taking care of 100 different patients. And if there is one person then showing signs that are maybe dangerous, or the supervisor could jump in and help, it can work, but you really have to put this to the test. I mean, I think this also happened already with the first AI systems. If you think about, Eliza, one of the first chat systems where you could talk to the machine and it would simply rephrase statements into questions. It turned out that in these systems already, the persons who have been in the lab developing the system, but also, assistants and so on, they at some point suggested, oh, let's study the chats and see what happened. And there was a huge uproar of many people in the lab. They said, no, delete those chats, because apparently they have been telling things to the machine, personal secrets, and seeking, a little bit of help, a little bit of brainstorming, thinking about different struggles that they had. So yes, it can be successful, but you also have to be careful that if you just let a system loose and do not screen it for potential threats, then really bad things can happen. And I think already a couple of weeks ago, we had a case where now parents are suing, I think, OpenAI because their teenage son committed suicide after interactions with the system. So it can work, but we have to figure out how to do it safely at scale, and obviously also in a way that people accept, trust, and find the treatment useful. If you just make it mandatory to chat with the machine every once a week for 30 minutes, that might not be the right way of approaching this.
Thank you. Let's now think about futures. I'm going to ask you first to be pessimistic. What are the things that keep you awake at night in terms of this work? that's going on? And what are you optimistic about? Where is your hope?
I might have a quite interesting stand on the pessimistic side, because I see, in particular in social media, maybe that's just me, but in particular in Europe, I see many people were afraid of technology. And they have a lot of fears. And sometimes these fears can lead to slowing down the technology. And then personally have the fear that we may end up at some point in a movement that is so afraid of the technology because it's hard to understand. It needs appropriate quality control. There are sometimes people that, Elon Musk, that make sometimes very bold statements that can incite fear in certain persons. I can understand that. But not everybody working in this field is an Elon Musk. Most of the people, virtually all of them, I don't have personal contact with Elon Musk, so I can't tell about him how he's as a person. But I can tell you that people working in this field, and particularly in the medical AI domain, they're very responsible. And they want to really build safe systems, making a change for mankind. And they also are very concerned about patient health information. They're concerned about the ethical dimensions of their doing. And I am sometimes afraid that these fear and overboarding regulations can yield or lead to a situation that will put us fall back. And you already see that, for example, the newest Apple products that are released in worldwide markets, certain features are not shipped in Europe because companies are afraid to release the products here. So there's I think 2 days ago, Apple released a voice-to-voice translation for their new headphones. The feature, for the time being, will not be released in Europe. Now imagine that for health. Imagine that the AI systems work well for populations around the globe, but Europe is misrepresented because we put regulations in place that will result in a worse treatment for the average European citizen. That would be really dramatic. Would like to avoid such a situation. And I see that there is so much opportunity in this technology. Obviously, we have to do it right. We cannot just go around and do everything that is possible. But if we do it with an appropriate regulation. So I'm not an enemy of regulation. I think regulation is very, very necessary, but you have to do it right. I can give you 2 examples. If you look at European regulation, the European regulation has led to all smartphones be having USB-C chargers, which is tremendously useful. You don't have to buy a new charger all the time. You go to your friend and he has the right charger. You can connect your phone, you can charge everywhere. So this is very, very good. But we see also that regulation, if it's not done correctly, can lead to very, very cumbersome and annoying things. Think about the cookie banners on the web pages. You see them every day, and they are very, very annoying. This is a way how regulation stops us from being productive. Now, the cookie banners right now, they're annoying. Imagine that happening to your health. You don't want to go there.
That's a great point. I remember the head of one of the financial regulators in the UK admitting that when his iPhone software updates, he has to scroll through pages and screens of legal text and just never reads it, just ticks accept. And I think you're right. The same thing with the new safety systems in cars, in the semi-autonomous vehicles. People find them actually quite distracting. They just want to drive and the thing is beeping at them and the bells are going off all the time. So I think it's a very interesting comment. The thing I love most about your answer to that was the fact that everyday clinicians and technicians, most of them are good people who want to do the right thing. We should trust them more. And I think that we have a collective bias for bad news because we're driven by fear. It's an ancient system. We're always looking around, watching for predators, people who are going to hurt us, things that are going to hurt us. And our news media, our news streams are just full of bad news stories. And I really love the fact that you are being quite objective about that. Yes, of course, we need the right regulation, but we need to trust each other more. And I really take a lot from that. Thank you. What advice, finally, would you give medical practitioners and AI systems developers right now in the area that you're working?
I think the most important part is that people talk to each other and that they develop a language that they can talk to each other. I've seen many AI and also machine learning specialists that, of course, they're specialists in their own domain and they love to do what they're doing. But if you want to address an interdisciplinary domain, it takes both sides to develop a common language and to work together. And in the end, you want really to push the field of medicine ahead. But at the same time, you can also push the field of machine learning ahead. So you now see that because we have these requirements on safety and so on, we see a lot of things emerging, physics-informed networks, known operators and stuff. There's new theory emerging in machine learning because we are pushing the safety and the understanding. And obviously, there is a mutual benefit from that. And they are required, both of the new insights in medicine, new insights in machine learning, but you have to talk to each other. And this is, I think, the most important part in this type of endeavor.
Wonderful. Professor Andreas Maier, Chair of Pattern Recognition at Friedrich Alexander University, thank you for being such an insightful guest on ChatRog and for sharing your fascinating perspectives on the driving purpose of AI in the quality of a good, pleasurable life for patients, given the resources available. The makers of AI medical devices always like the physician to take the final legal responsibility for harm. And one of the most colorful images is the holographic doctor from Star Trek Voyager. Probably won't ever happen, or if it does, not for a long time. So thank you so much for joining us, Andreas. You've been our first expert on pattern recognition and the application to medicine.
Thank you very much for the invitation. It was a pleasure to be here.
And to our audience, thank you for listening. This episode is available both as audio and video in all the usual places. If you're usually a listener but would like to watch the conversation, search for ChatRog on YouTube. If you'd like to take this discussion on the go as you go for your walk or your commute, download the audio version. We really appreciate your feedback. Please comment on the podcast. We're still growing and learning, and your thoughts are incredibly valuable. And it helps enormously with the algorithm. If you like and subscribed, and if you're so inclined, leave us a 5-star review. Join us next time as we continue the ChatRog question, not just to understand what AI is doing in our world, but what it should be doing.